Quiet Signal, Technology, Signal. Wednesday, August 19th, 2026. Season 1, Episode 23. This is Dragon Tom. Here's your weekly technology signal. Capability Notes 1. Spacecraft demonstrate GPS-independent navigation using other objects in orbit. NASA's Starlink satellite swarm successfully demonstrated Falcon, an autonomous optical navigation system that determines a spacecraft's orbit by observing other satellites and orbital debris rather than relying on GPS or continual tracking from Earth. During a 3-day experiment, Falcon also improved the estimated orbits of more than 200 other space objects without ground intervention. NASA says this is the first spacecraft demonstration of optical self-orbit determination based on relative positions to cataloged objects. Capability Threshold. Spacecraft are beginning to navigate by looking at their surroundings and figuring out where they are themselves. That matters beyond Earth, where GPS disappears and communication delays make constant ground control increasingly impractical. The same architecture could support autonomous lunar satellite networks, deep space swarms, collision avoidance, and distributed exploration missions. Later this year, NASA plans to have Starlink's 4 spacecraft share their observations and refine their positions collectively. Institutional sources. NASA Ames Research Center, NASA Small Spacecraft and Distributed Systems Program, Aerodrive, and Stanford Derived Technology, August 17th, 2026. 2. AI begins detecting dangerous solar regions before they become visible. NASA's COFFEE's Research Center developed a machine learning system capable of predicting the emergence and approximate location of active regions on the Sun, up to 12 hours before they appear on the solar surface. The system analyzes subtle changes in acoustic waves and magnetic activity produced while magnetic structures are still rising through the Sun's interior. Current operational space weather forecasting largely evaluates active regions after sunspots have already become visible. The new sliding window transformer instead searches Solar Dynamics Observatory data for precursor patterns that humans and earlier algorithms have difficulty extracting. It is not yet an operational forecasting system and still requires broader validation. Capability Threshold. Space weather forecasting is beginning to move from seeing the threat and predicting what it will do toward predicting where the threat itself will appear. Combined with the Punch solar storm tracking capability reported earlier in this series, this points toward an increasingly continuous warning chain. Detect potentially dangerous solar regions before emergence, characterize eruptions, and then track resulting storms toward Earth. Institutional sources: NASA COFFEE's, NASA Ames Research Center, New Jersey Institute of Technology, Princeton University, and NASA Solar Dynamics Observatory, August 14th, 2026. 3. Engineers create a design language for materials that behave like living structures. MIT researchers demonstrated a mathematical framework that translates mechanisms found in biological structures directly into manufacturable adaptive materials. Instead of merely copying the appearance of something like a pine cone, the system describes how its fibers, tissues, and larger structures interact, substitutes engineered equivalents, validates those relationships mathematically, and generates instructions for 3D, printing the resulting material. Researchers demonstrated the approach by combining mechanisms from different biological systems to create a new temperature-responsive twisting actuator. The fabricated device behaved as predicted without requiring the researchers to redesign the complete mechanism from scratch. Capability Threshold. This begins turning nature from a collection of designs engineers imitate into a library of reusable mechanical building blocks. The longer-term target is physical AI, systems in which artificial intelligence can discover useful physical mechanisms, combine validated components, generate manufacturing instructions, fabricate the object, and eventually test the result. Potential applications include self-adjusting aircraft structures, passive robotic grippers, biomedical devices, and